Hi there, I'm Alex Feisley. I'm the CEO of Gravital, and I'm here today to give you a quick demonstration of how to set up a Kubernetes cluster that spans multiple clouds using Netmaker, K3S, and WireGuard. So why would you want to do this? Well, let's say you want to be able to control multiple environments simultaneously. You don't want to deploy multiple Kubernetes clusters because that's a lot of work to manage, and you want your deployment to be a lot easier. So let's say you're installed in AWS and GCP. You need to move an application from one to the other. That's typically pretty annoying to do. Or maybe it's Azure and on-prem, and you need to move between Azure and on-prem. It can be a lot of work, but if you have a single cluster that spans clouds, it's a lot easier. So this is just a little demo of how to do that. We're not setting up Ingress, we're not setting up storage, and we're not doing HA. That's all just to make this as fast and simple as possible. But we'll do that in a future video, and if there's anything in particular you'd really like to see, just let me know in the comments. Okay, so we have 3 nodes here. Keep it short and simple. So we have AWS, Linode, and Vultr. So we're going to create a single cluster where AWS is the master and Linode and Vultr are workers. So let's go ahead and create a network, call it K3S. And there's our Netmaker network. And let's make an access key. And give that some uses. And there's our install script. So let's just go ahead and install that. There's 1, there's 2, and there is 3. And Vultr appears to be running a little bit slow today, so we'll see how that one holds up. Okay, so that one went through. Let's take a look back in Netmaker. So back here, we've now got our 3 nodes. We can give them names that make sense. So we could just call it master. This is our AWS instance. Worker. This is our Linode instance. And one more worker. And that is Vultr. Now back over here. We can take a look at WireGuard show, make sure it's coming up correctly. So my concern is Vultr is going a little bit slow, or maybe has some DNS resolution issues. So let's go ahead and ping these addresses. Yeah, it looks like it's going just fine there. So let's ping our hosts. Okay, so that seems to be going fine. Let's check AWS and just do 1 ping there. Make sure everything looks hunky-dory. And okay, that's good enough for me. All of our nodes should be fully meshed into a single network, and we're ready to deploy Kubernetes. So again, we're doing K3S. This has a couple advantages. One is that it can run on very small machines. The other is that it can run with SQL Server, which is latency tolerant. So if you were to actually run this as a production cluster, you'd have a little bit of difficulty with etcd, which is the standard database for Kubernetes. So K3S might be a good choice there. And in future videos, if we get some interest in doing that, we'll talk about how to set up a production-ready deployment using this methodology. But for now, let's take a look. And that's beginning to spin up. so we can go ahead and add our other nodes. For that, we're going to need our token. There is our token, and then we are going to set it up here. Okay. And these quotes came out a little weird, but we're going to connect to our server, which is running on that address. We're going to put in our WireGuard address there, and then we just need this token value. So basically how this works is all the traffic is going to run over Flannel, but through the WireGuard interface. That's the NM K3S there. Let's grab that command and bring that over to Vultr. And again, seems to be having a bit of problem with DNS resolution this morning, I think it is. We'll find out how that goes here. All right. Yeah, that looks like that's going a little slow. Okay. Let's try that one more time. I think everything's set up correctly there. Agent, server's correct. Okay. There we go. So assuming it's able to reach GitHub there, we should be good to go. We'll find out. Okay, there it goes. And it's beginning to spin up. So let's do a quick kubectl get nodes over here. All right, and Linode should hopefully be up soon enough, or Vultr. And once Vultr is up, we can move on to the next section. And let's make sure of that, because this seems to be the problem child this morning. Let's do a system ctl status K3S agent. Okay, looks like things are starting at least. And let's check get over here. Okay, we've got all our nodes. So from now on, we're just going to run off the master to run our kubectl commands. And we're just going to run a couple tests. So we are going to run a set of pods on our 3 nodes and make sure they're all able to connect to each other. So we have a special deployment called ping test. So I'm going to go ahead and create pingtest.yaml. And let me grab that YAML. And we have a tutorial in the comments which you can use this YAML and other information, make it a little bit easier. But it's basically just going to run the replica set on the different nodes using node anti-affinity. So it's telling it don't run on the same node. Okay, and we're going to do kubectl create namespace ping test. And then we're going to do kubectl apply ping test. Okay, and let's take a look. So we've got 3 creating. Looks like Vultr's running slow. That's going to be the problem child, so we'll see how that comes up today. But yeah, beyond that, we are ready to begin our test. So let us move on to the next part, which is execing into these pods and making sure we can communicate with each other. So we'll start with an exec command. So it's going to be kubectl exec it, and let's go ahead and we're already in AWS. Let's exec into this one running on Linode. And give ourselves a shell. So let's make sure we're able to ping AWS. And there we go. So a pod network running on Linode is able to reach out over the overlay network for Kubernetes and reach a pod running in the other network, and this is getting encrypted and decrypted and route, which is really great actually. We still don't have that other node. Let's make sure it's up and running. It is now created, so let's make sure that we can reach that one. And this is going to be the real test, because apparently this one's having some sort of, looks like it's running fine. Okay. So our internode communication is actually running very well. Let's make sure that we can do this from Vultr as well. So we're gonna shell into this problem child here, and let's run that same test to make sure we're able to reach these other guys. So Vultr doesn't appear to be having problems with IP addresses. It appears to be some sort of DNS issue going on over there. I'm not sure how they set up their resolvers, but something to look into. Okay, so now that we're back here, let's run our last test, which is service resolution. So we're able to resolve IP addresses of pods, but can we resolve cluster services? For that, we're going to run a different test. So let's create a new namespace. And in that namespace, we're going to create an Nginx deployment. So it's just a simple Nginx deployment with a service. And what we're testing is to make this DNS is functional. So we're just going to run a kubectl apply. And there, we have created our deployment and our service in the Nginx namespace. Let's wait for those to come up. And look at that, we've got one running in AWS and one running in Linode. So to test this, let's do ping test again, but on that Vultr pod, and see if Vultr is able to curl, or wget rather, the front page of this Nginx server. So, okay, we're going to run a exec again back into that Vultr pod. And here we go, fingers crossed, we're going to run wget against the service name. So it's nginx dot nginx dot svc dot cluster dot local. And that's it. So from a pod running on a host in a different network, we're able to use cluster DNS to resolve a service name, load balance to an Nginx pod running on another host, and grab that HTML. So this demonstrates that we have a functioning network over encrypted lines across clouds using Netmaker and using WireGuard and using K3S. So again, if you found this interesting, let us know in the comments. We're happy to do other demonstrations that are maybe more thorough and in-depth, going into distributed storage, ingress, and of course HA, which you would need for production deployment. So yeah, thank you very much for watching, and I'll see you all soon.